Hi, I'm going to do this quick run through a second challenging KP question. So again, it's one that includes data in the form of a percentage of the original compound that actually reacted, as opposed to giving you moles that you can just plug straight into your calculation. So we've got to try and create the numbers that we need in the form we need them to put in our KP expression. So I'll come up with the expression for KP a little bit later on in the video. I start off by taking you through how I'm going to use where it says in an experiment 81% or 81.3% of the sample of N2O4, which is this, was found to have dissociated, broken up in other words, into NO2 at an equilibrium pressure of 100 kilopascals. So if we imagine we're losing 81.3%, and we start with 1 mole. So it doesn't tell us how many moles we actually have. So we can actually then just say basically 1 minus 0.813. So 0.813 is a decimal as a percentage of 1, isn't it? So that gives us the opportunity to then use the number of moles of NO2. So if you've got 1 mole of N2O4 reacting, you'll have 2 moles of NO2 being made. So that gives us these mole values at equilibrium. So then we add them up to get the total number of moles. So now we have the mole fractions, or the means to work out mole fractions. So we take each moles at equilibrium, we divide it by the total to get the mole fraction. And you can check the mole fractions, do they add up to 1.813? So if you wanted to just quickly run that through a calculator to prove that to yourself, you can then see they do. And then you get the partial pressure, which is what we want to put into the KP expression. So they made it easy for us in a sense because they gave us 100 kilopascals, so we can almost do that one in our head, can't we? So checking that our 10.3 and our 89.7 add up to 100, which they do, that's our KP expression. Those are our numbers, and we end up with 781 the 3 significant figures. Now the kilopascals came from the fact that it was kilopascals squared on the numerator and kilopascals on the denominator. So divide one by the other and you end up with kilopascals as your unit. Okay, hopefully this was useful. Again, thanks for listening. Until next time, see you soon.